Get up. All right, you guys all have your quiz open?
Yes.
So number one, sorry, I'm just opening all the links that it has here. Like 300 windows open right now. Okay, so we start with number two. Which of the following variables are quantitative? Mark all that apply. I marked B and C, but I wasn't sure if number one, because it had numbers in it, was also quantitative.
The three most common brand of car is qualitative, or that's it doesn't count as, or whatever the other one is.
Is not quantitative?
It wouldn't be.
Okay, so it's A and D and C?
I don't know if the telephone number is. I can't remember. I always have.
I think the telephone number you can't change, just like zip codes.
They like the thing that I remember. Like if you can add or subtract from it, then or put it in an equation, then it's quantitative. If you can't, and it would just be a variable that stays the same, then it's the other kind.
That's so funny because I didn't realize I was on mute just now, and I was saying the exact same thing that you were just saying. And then I was like, wait a minute, we're talking at the same time.
Oh, that is so funny. That's hilarious.
So for quantitative, this would just be C, right?
Yes. Yeah, I think so. Oh my gosh, Albertsons. That's hilarious.
I'm going with B on this one.
That's what I chose.
Yeah, I'm okay with that. B as in boy.
Mm-hmm.
Yeah.
Yes.
I think this one is C. You can't tell the median with the amount of information they've given us because we don't know what the highest and lowest number were. So how will we know what the middle is?
Yeah.
I can't remember the equation to figure this one out.
Okay, so for this one, the 68, 95, 99.7 rule is that within one standard deviation will be 68% of the data. Within two, it will be 95, and within three, it'll be 99.7. So they've told us that the mean is 70 and the standard deviation is 10. So each deviation will be 10 away from 70. So if they tell us what percentage, what was it, 50? What percentage? 50 minutes? Yeah. So 50 minutes is going to be 2 standard deviations away. So that would be
you multiply by 2 throughout the equation.
Under 50 minutes. So 2 standard deviations away would be 95%.
What answer is it looking for? The percentage?
It's saying less than. Okay, so we know that 50 minutes is going to be 2 standard deviations away. So we know that it's going to be within the 95%, like 95% of the data is going to be. So it says how many people or what percentage of people will be under that. Well, if 95% of people are that, then only 5% of people would be under that. Does that make sense?
Yeah.
But now I'm double checking my memory. I'm like, wait a minute, is it 2 or 3? Because the answer wants it to the 1 decimal.
Mm-hmm.
So that's kind of throwing me off. Like, oh,
Right.
maybe it's not. Maybe it's 2 standard deviations away is the 99.7. Let me double check that.
I just remember I didn't ever get this one right.
Wait a minute. Yes. Okay. So yes, 68% is within 1 standard, right? And then the 95 is within 2, and then 99.7 is 3. It has to be that, but I'll double check it just to be sure.
Is it part of the equation like a plus or minus as well?
You can do an equation. There is an equation for figuring it out, but for this one, they want you to do it like mentally.
Oh.
So that's they like actually specify using this rule instead of using the equation. Using this rule, figure out what it is. So I'm going back to figure out what lesson was that? Holy moly!
I know.
Yeah, I don't even know.
I think it was
Way back in the beginning.
maybe it was.
Which is kind of scary that basically the test is on everything.
Yep. It's going to be great.
Yeah, I'm super nervous about that because I worked on this homework tonight for an hour and 45 minutes, and I'm telling you right now, I only got to like number 28. So I was having to go back and read so much stuff.
Yeah.
Yep. I cannot find this now. Is it in 5? Okay, yes, I found it. Okay, yes, 68 is within 1, 95 is within 2, and 99.7 is within 3.
Okay.
So okay, so yeah, it's U minus 2 standard deviations equals. Yeah, so I'm going with the point. Okay, wait, let me go back to the question again so I can look at it. Okay. If it's 2 standard deviations away, that means that at 95% is going to be there. Less than that would be less than 95%. So it would be 5%. So it would be 0.05. But oh wait, they want it. They want to know as a percentage or what? I don't know.
It says give your accurate to 1 decimal place, and we're at 2 decimal places.
I know that's what. That's why I was like, well, do they want it as a percentage or what? Let's see. 70 minutes. 2% will finish. 5% will finish. So do we write that as like 5%?
5.0?
Yeah, like.
Well, let me ask my friend who took this review already. Let's,
Well, then that would round up and it would be 0.1. 0.05 would round up, so that would be 0.1, right?
Yeah, that's right.
I like wouldn't know what else to put there.
So we know that 95% of the people taking the test
Mhm.
finish the exam in 50 minutes or in.
Yes. So 95% of the people did it within 50 minutes or greater.
Oh crap. Okay,
Hold
so
on,
she said.
I'm looking for the actual equation to see if we put it in the
Yeah.
equation.
Because she gave me the answer and it's nothing close to what we got. And I said, how did you get that? She's like, I have no idea how we got that. I'm like, well, that's
Okay.
not helpful. And how are you going to duplicate that?
Okay, so we will use. What was her answer?
2.5.
Hmm.
She said, oh, this is why you're not supposed to ask other people for help. But she said one of the girls in her group got it from one of their previous quizzes. Now I want to open every quiz.
Okay.
Which quiz would that be in? Do you remember what lesson that was from?
Yes, it's from lesson number 5.
Okay, I'm going to try and see if I can find it real quick. Not that that will help us, but maybe this will be worded differently.
The mean of 159. Okay, I figured out how to do it.
Okay, let's hear
Okay,
it.
so you have to get the z-score first. You get the z-score by doing the, hold on, let me look for it again. The like the proposed one that they're telling the x value or whatever, which is 50,
Uh-huh.
minus 70, which is the mean, divided by the standard deviation, which is 10. And that does not look like a z-score. So let me try that one more time.
So it's 50 minus 70 divided by 10. I got negative 2.
I was like, that does look like a z-score. Okay,
Yeah.
which is 2 standard deviations away. Duh. Okay, so then.
Okay, so what do we put? It's
Okay.
less than.
Yes, you put that z-score in and then do less than. So that's going to be shaded to the left.
Yeah, so the area is 0.0228.
Well, that's what it says. I don't know why.
It makes sense. I like it, but it doesn't match what they got. So, I mean, not that I'm saying we should listen to them, but even if we round up, it would only be to 2.3.
Unless we're writing it as a percentage, right? And if we were just writing it as the percentage instead of like doing the decimal percentage, like writing it as a percentage, it would be 2. Yeah, you're right. It would only still be 2.3.
Mm-hmm. I don't know what to do here. I mean, we have another chance, so we could always go back, but
I want to put in 2.3 and see if it accepts it as right. Because I know one time she said that there was like a range of values that it will take.
Oh, okay.
Okay, I just found the same question
Mhm.
in lesson 5's homework.
Oh, I didn't get to the homework. I was at the group quiz. Okay, what'd you get?
I think it's supposed to be, it says question mark. Wouldn't you know? Yeah, this is the one I always get wrong. It says 16%.
And it's the same numbers?
Let's see.
Okay, I found it. It's question number 1. We put 2.3 as our answer. Oh no, sorry. This was my own personal quiz. I put 2.3 as the answer, and I got that one wrong. It was 2.5. So it says the time to complete a standardized exam, blah, 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 is approximately 70 minutes, standard deviation 10, using 68, 95, 97. What percentage of students will complete in under 50 minutes? And I put 2.3. The correct answer is 2.5.
You know why? Because 2.3 is what you're going to get if you do the actual, like, the equation. But you're not going to get that if you do the using the rule. It's not going to be as specific.
Right,
But I
right.
don't know how you figure it out using the rule.
Right. I wonder if she'll watch this and give us some feedback.
Hold on, I'm going back through this lesson and seeing if I missed it somewhere. Okay, let's see. That's how to compute it. Okay, wait. Oh, okay, I get it. All right, guys. So 95% will be within 2 standard deviations. So on the ends, you're going to have 2.5%. Like if 95 is in the middle, you're going to have 2.5% on each end.
Ah, yes.
So if you have
Have that 5% left.
right, instead of being 5%, like I said, I didn't take into consideration that 2.5% of that's going to
Be on the other side.
Yeah, on the other side.
That I never would have gotten to by myself, which is why I got it wrong the first time.
Well, I don't think I got that one right before either, but I'm glad I sat here tonight and worked that out. Okay, let's see. Where is that? Where does that even go? Oh, number 5? Is
Yeah.
that number 5? 2.5. Okay, and I'm going to make a mental note too that when it asks that to give it in a percentage, it means like actually in a percentage, not in decimal form.
Yeah.
Okay, because I bet I've missed some before because of that. Let's see, scores. Okay, this one I figured out, I'm pretty sure. This one, because this one says to use the applet and use the thing. So I got 146.773.
146.773, right?
Yeah, is that what you guys got?
I didn't. This is another one. This and the previous question early on were my Achilles heels. I just had a really hard time with this percentile stuff.
Okay.
I'm gonna do it real quick.
No, I'm looking at this going, did I do it right?
That does not look like a z-score. What did I do wrong? We need a z-score, right?
Yeah, you have to calculate the z-score and then put that into the app.
Okay, so it's 157 minus 150.7, right?
That's what I did.
Divided by 10.2. I got 0.617. Can that be a z-score?
Yes, that can be a z-score.
All right. So less than 35%
Would be to
sorry, find 35%. Would be the one shaded to the right.
less than is to the left.
Sorry. Give your answer in accurate 1 decimal place.
Oh, wait, so they want the...
I did something wrong, or I'm not getting the same answer as you.
Okay, hold on. Let me go back and look and see what I did. I gotta look at the question again. Normal mean of this, standard deviation of that. They require 157.
Find 35 percentile. So I got 0.268. And I don't know.
So something's fishy here to me. It says find the 35th percentile of the LSAT scores. Why would we even need the 157? We don't need that. That's like extra information.
Mm-hmm.
And it really doesn't have anything to do. So now that makes me want to come back in, because of course I didn't write like my math out in any kind of way where I can see what problem. I just have like a bunch of scribble scrabble all over this page. So I don't even know how I got to that answer now. Where did I find that? Was that 7? Okay. Percentiles, and in the area under. It seems like we would have to turn a z-score into a number somehow.
Mm-hmm.
So we could get the z-score for 35% by just putting that into the like 0.35 and shading what's to the left. 0.35. And that gives us our z-score of, do I have that number written anywhere down on here? Yes, I do. Okay, I found my equation. Yay. 0.385. Okay, so I have negative 0.385 equals x, because that's what we're solving for, is we want to know what
The 35%
is. So it's x minus 150.7 divided by 10.2. And then you solve for x.
Could you do that one more time, Lindsay, really slowly?
Yes. Okay, hold on. I'm going to actually see if I can translate this. Okay, so we want the z-score equals x minus the mean. Okay, it's going to be the z-score for your probability.
Mm-hmm.
So the corresponding z-score equals x minus the mean divided by the standard deviation. And then you solve for x.
And you got the z-score by typing in the 35% in the applet first.
Yeah, I put that in the applet, and then I made sure that, well, first I made sure that the appropriate section was shaded. So in this case, they want to know less than 35%. So I did it shaded to the left, and then I typed in the 0.35.
Up in the area.
Yeah, for the area, and then it gave me the z-score.
Okay, so after doing that math, I got negative 14.7.
Okay. Let me double check my math.
I mean, I'll do mine again too, but
let me see, that doesn't really seem right, because like that number wouldn't make any sense if we wanted to know the 35th percentile of
The scores.
the scores. A negative number wouldn't
Right.
make sense.
Okay, so are you using 0.385 as the z-score, or is it a negative?
Nope, I'm using negative.
Negative. Okay, hang on.
5 negative. So basically what I'm doing is negative 0.385 times 10.2.
Negative 0. Uh-huh.
And then plus 150.7.
Plus, I thought it was minus.
Well, it's negative on that side. So in order to cancel it out from that side of the equation,
You do both sides.
Mhm.
Okay, so back to 10.2 plus what?
Okay, so once I did the negative 0.385 times 10.2, and then I added 150.7.
That last number one more time.
150.7.
So what's our final answer?
I got 146.773.
Would we round that up to 0.8?
Yeah, because it's just the one decimal place.
Then yes. 146.8.
147.8.
6.8.
146.
The known, the distribution. Okay, on this one, my instincts tell me that it's either going to be skewed right or we can't be sure. Because
I
the
chose we can't be sure, but
N is not sufficiently large to
Mhm.
assure that it's going to be normal, and it definitely would be skewed left. But I don't know if it's if skewed right is gonna always be skewed right, or if it's like we won't know until we examine. So I don't know what that one is.
Well,
What
it does say it is known that the distribution of the number of cancer spots is right skewed. So
Right. So
going just by that, N is not much.
right, that N2 is not very much at all.
I don't think we'd be able to even see a pattern with 2.
Right. Well, and the thing I was thinking about is just because your original population is right skewed, it doesn't guarantee that your sample will be.
Yeah.
We just know that we have to make sure that our sample is sufficiently large to guarantee that it won't be. But I don't know that we could tell that unless I think we can't be sure.
Yeah, I don't think we can be
Reasonable.
sorry, I muted myself, but I agree.
Okay. Okay, what did I get for 8? Wait, what is, no, this is 7. Oh, that was helpful.
Okay, I'm on number 8 with the tanker trucks. Is that where we're at?
Yeah.
Okay. All right.
The Z-score that I got when I did this was 2.236. That being said, I wasn't altogether sure if the way the question was worded, I didn't know if we were supposed to use 8550 or 8544 because it said, let's see, it says it's known to be, or let's see, a factory manufacturer's tank truck. They claim them to be 8550, and our sample was 8544. But it says, where did it say that? And then it says the actual capacity is normally distributed with as 8554, but then the question says the mean capacity is found to be 8550.
Right. I think we use 8550.
I think we do too in question 8 at least because it specifies.
What did I do? What did I end up choosing? Yeah, I think I ended up using 8550. I did 8550. Wait, maybe I did it backwards though. Let's see. Actually, so no, because it's going to be X, so the X would be 8550. X minus U, which is 8544, divided by 12, which is a standard deviation, divided by the square root of 20, which is the sample size. That's what I did. And I got 2.236.
I'll take that. I think that sounds good actually to me because that can be a Z-score.
Right. It looks like a Z-score. So I was like, I think I did it right. And when I did it the other way, I got 0. And I was like, okay, I don't think the answer is 0. I don't think I did that right.
Right.
Hey, quick question. When you do 8550 minus 8544, then it's divided by 12, right?
Uh-huh.
And then you take that and divide it by the square root of 20, but you have to square root 20 first, right? You can't do it all in the same action.
Well, the way I do it in my calculator, because it has this capability, is I'll do the top number first, which in this case, I think it came out to be 6. And then I'll go divided by, and then I do parentheses, 12 divided by 20 square root parentheses. And then it does it. But if I didn't have a calculator that did that, I would do the top, and then I would write that off to the side. And then I would do the bottom, and I would do the square root of 20 first and find out what that is. And then I would do 12 divided by that number. And then whatever that one was, then I would do the top divided by the bottom.
Okay, so I got 2.683.
Oh, no.
Yeah.
All right, let me double check my math.
So 20 square root is 4.4721359. Let me see this again. 8550 is 8544. 6. Sorry, I missed one step. Divided by 12. And it's 0.5. And then we go
2.683.
0.5 divided by 4.472. Oh my gosh, that's not right either.
Okay, I got your number that you were that number that you calculated.
2.683.
Yeah, that's just the bottom of the equation. So now you have to do 6 divided by that number.
I see. $2.236. Look at that.
That's what I got.
Awesome. I just got
So
that.
why when you go 6 divided by 12, where does that number go?
You don't do 6 divided by 12. You do 6 divided by 12 divided by the square root of 20. So the
Okay.
bottom of the equation is 12 divided by the square root of 20. And then
Yeah.
then the 6 is on top. So then you have to do 6 divided by that.
Okay. This is going to be a fun final exam. I do not remember this stuff from chapter 5. Oy.
And neither do I. That's why I've spent so long today.
Right.
We're going back. Or what's that? What was that? And then I never did make a note sheet for that exam because I didn't know that was something that you could do. So the last chapters I have all these great notes for, but the first chapters I just have like random stuff written around in my in my notebook, not all consolidated in one place. So it's been real fun tracking all that stuff down today.
Mm-hmm.
Okay, number 9. What is the probability that the sample mean capacity of 50 will be greater than?
So this is where we put our z-score in.
Yes.
And greater than, I got, oh boy, 0.0127. Is that right?
Okay, hold on. Let me read this question again. What is the probability that the sample mean capacity?
Or do we have to do that calculation again?
With 800, with 850.
With 885.40. Yeah. That's lame.
Okay, yeah. I did the calculation again with 8540 and got a, what did I get?
Okay, I need to do it again too. Otherwise, I'm never going to be able to do this.
And don't we have to change the N number to
Yes, to
50?
Mm-hmm.
Okay. All right. Minus 8540 equals 10.
Wait.
What is it being divided by? 50?
50. The square root of 50.
Ew, the square root of 50. What is the number? Maybe we don't have that number this time. Number 12. Where does that number from the last equation? But I don't think we have it in this one.
It's
Well,
the
this one
same.
you
It's the same information.
It's the normal mean that they found.
Mhm.
Okay, so we would still use 12 in that place.
Yes.
Mhm.
What are the two numbers on top? Which order are they?
I have 80. It's x. It's x minus u, and the u is 85. What was it? Gosh, they gave it to us. Let me write it again. U is 8544.
Oh, I did it wrong. Oh my goodness, 8544.
So it's
8540.
8540 subtract 8544. Then
Is a -4.
yeah, divided by the
12.
square root of 50.
So
Oh, wait.
8540 minus 8544.
Yes.
Got it. I always get those two mixed up.
7.07. Okay, so then we go 4 divided by ew, I got negative number. Did you guys get a negative number?
Hold on, I'm still doing it.
I got negative 2.357.
That's what I got.
My gosh, what am I missing? I got negative 0.565.
That can still be a z-score. You just have to put it in and then find the percentage of the probability of the greater sample.
Is
Yeah, this is the z-score. You're right, and then we have to put it in and find the probability. Isn't that what it asks for? Probability.
Yeah, it asks for
Yeah.
probability. So put it in as the negative, right, on the negative side, and then shade it to the right to find the probability of the greater than 8540 gallons.
is 0.286.
Yeah, that makes sense.
Okay, I got the probability as 0.991 after you round.
0.991.
Yeah, I put in the z-score of negative 2.355, and then I shaded everything to the right.
All right, negative 2.355.
355.
And shade to the right.
Mm-hmm.
You're right. I got 0.9901 or 07.
Mm-hmm.
0.99 what?
It would be 0.91991.
All right. So did everybody get that one, number 9?
Yes.
Okay. Number 10 is, I believe it's the probability of a type 1 error. I have like that exact sentence written in my notes.
Awesome.
So I was like, woohoo. What did I
You're
do?
like, I know this down. I'll take it.
Oh, number 11's not bad either. It's like that interpretation. But except it says more than one, or mark all that will apply, and I missed that the first time. And I was like, wait a minute, I'm pretty sure it's more than one of these. I was freaking out.
So we find that we are 95% confident that the true mean of blah blah, and then
And also C.
yeah.
I always get these ones wrong.
So I got D, right? C
I was
is
thinking
we don't have a chance though, because it's not chance.
I have A, B. Well, I mean, they're not labeled A, B, and C, but like the third one down, maybe they're in different orders for each of us too. I've had that on other tests.
Yeah.
So I have,
we are 95% confident that the true mean height of adult females in the United States are somewhere in our confidence interval.
that's good. I like that. And how about 95% of the height of female adults in our sample are in our confidence interval? Does that work?
Yeah,
wait,
that is
which
also one.
Which one?
95% of all the heights of the female adults in the U.S. are in our confidence level interval.
No, that's not one.
No,
That's
Oh,
not
you're
one.
right. So it'd be
the other one. It's the other one.
approximately 95.
No, the 95% of the heights of female adults in our sample are in
I
our
don't think
confidence.
that's it either. That's not what that's not what they're saying. The confidence interval is just, it's just saying how confident we are of the true mean. So it does all of the height, 95% of the heights may not be in there. I mean, it's not asking about the heights, it's asking about the mean of the heights.
Oh, okay.
So the only two that I see that are correct are the one that says approximately 95% of all 95% confidence intervals that could be computed from the population of adult females in the United States will contain the true mean height. So
Yes,
that
and
one, and that's the first one that we all agreed on, where it's 95% confident that the true mean height of adult females is somewhere in our confidence interval.
Yep. Yep.
Oh my gosh, this is still going to be so long. There's 47 questions.
Yeah, we're gonna be here all day.
Okay. I'm glad we got started early today.
Yeah. Sorry. What was the other one for number 11? It's.
Which one do you have?
I have 95% confident that there's true height of adult females in the United States somewhere in our confidence level.
Then we have
That's not
the approximate. Oh wait, do you
Okay.
have the approximately?
Well, no, but I'll click that one now.
Yeah.
Okay. Are the requirements for this use of a confidence interval met?
And what did I put for this one? 12. Okay, let's see.
Well, do we know if the data is normal? I don't think we know that.
Yeah, it says their data follow a normal distribution. So I would say yes, the distribution of the sample means is normal because the data is normal.
Okay, so that's B for me.
Mm-hmm.
Oh, this one requires a spreadsheet. I only opened
Yeah,
some of them.
Let's see what
I
number.
might just let you tell us the answer then, because I didn't open that quantitative review.
Okay, I'll just
whatever.
tell you what I did. So what I did was I opened up the rates of return and there was all these numbers in there and I highlighted all those numbers and I put them into the, what is this thing called? Quantitative inference procedures sheet under the one sample t-test. And I put all those numbers in and I made sure.
Go ahead.
I made sure that the confidence level was 95 because it says so in the thing. And because it said, let's see, what does it say? Suppose conduct a hypothesis test to determine if the investor's portfolio performs significantly worse than the performance of the S&P. So I put it to less than because that would be significantly worse, correct?
Less
And
than.
when I put it in at less than at 95%, it gave me a p-value of 0.019.
19.
Yep, 0.019.
I remember doing that problem like
Yeah,
a while
The
ago.
same one?
most of these questions I remember doing
Yeah.
at one point or another.
I do not. You guys have good memories. We're going to need all of those spreadsheets from the quantitative Excel thing, aren't we?
Oh, yeah.
Yeah.
That's terrible.
Okay, I think this one is dependent sampling.
Gosh, I remember this one.
Yeah, I remember this exact question. This
Mhm.
dependent sampling. He needs to select so he needs to select couples for the sample. So whether a particular wife is included depends on whether her husband is included.
Right. I agree.
Okay. Moving right
What
along.
would you for 13? I'm sorry.
It's 0.019.
Okay, I missed the number.
Guys, we're like a third of the way done.
I know, when we're done after an hour. So we've at this point we've got about 2 more hours to go.
No.
Okay, number 15. What is the p-value for this test? Okay, so this one I copied and pasted the information from the direct flight cost into the that same quantitative inference procedures, but I did the paired sample test.
Because we have to find the differences, right?
Right, we have to find the differences. And then I set it to, what did I set it to? Wait, let me make sure this is the right one that I still have set in here. What is it asking for?
The p-value of
Value. Okay, so p-value. Yes, this is the same one. Okay, so I set it to 95% confidence level and not equal to, because it says that she wanted just to know if they were different, if there's a difference in the price. So that means not equal to. And the p-value that I got was 0.0956. So I rounded that to 0.096.
0.0996.
0.096. And then based on the results, can you say there is a difference in the cost of the airline tickets? So the null on this one is that they're the same. The alternative is that they're different.
And our alpha is 0.05.
Right. So
It's no.
right.
Because
our p-value is greater.
Yeah, our p-value is big, so we don't reject the null.
Yeah. Boo. Oh no.
Oh, we did this one recently too.
Yeah, I
Yeah.
remember this one.
And this one, I believe, is not necessarily, because the company needs to check that the values given by each appraiser are normal, not that their differences are normal. Because when I looked up the requirements for this type of test, it said that the data has to be normal. What did it say? Let me find my notes again. For each population is normal. If not given, check against a QQ plot, is what it says.
Cool.
So, didn't say anything about the differences being normal, so that's why I went with that one.
the not necessarily.
Yeah, not
That's the
necessarily.
one.
Yep, they need to check that the values given are normal, not that their differences are normal. How suppose the company the previous question hypothesis test. Okay, and what did I pick for that one? I think I picked.
I picked C.
HOU1
Aren't we?
equals to U2. U1 is, I have A. U1 is equal to U2, and the alternative is U1 is not equal to U2.
Yes, I would agree with that because this is we have two different pairs of data with means.
Wait, let me read it again.
Are we going? Are
You know
we
what,
going
maybe,
for
no,
differences?
it might, I think you were right, Donna. I think it's C, or whatever you said.
Yeah, C.
Wait, U1. Because they want to check the differences, right?
Yes.
Oh, I see what you're saying. So there would be a difference of 0, or there would not be.
Right. Hypothesis is UD equals 0 and not equal to 0. Yeah. Dependent pairs. Close the door. No, I'm not all done.
You flip.
Let's see.
I hate these ones.
Right. I think it's D.
I do too, but that doesn't mean a lot. Just
Why wouldn't it be A? There's a 95 chance that the true mean is between this.
Because it's
Oh.
never a chance.
Yeah,
Ah.
avoid chance.
Avoid chance. Okay.
And since we're looking for the sample mean, and it specifically says sample. Oh wait, are we looking for?
It says the true mean.
Oh, so then
It's-
just kidding. I would go with B.
That's what I picked, but I didn't know why to say that's what I picked.
it's B.
Yep.
All righty.
Oh man, I hate p hats. Oh.
Okay, so this one is one that took me just a little while to figure out, but this is the one where in order to satisfy the requirements, oh, let me get to my notes before I start saying something that's not right. It was like, where is it? Where are the notes for this? Here we go. Okay, a normality is n times p is greater than or equal to 10, and n times 1 minus p is greater than or equal to 10. And they're giving us p, which I just turned into a decimal of 0.8 for easiness sake. And then I just kind of solved for x. So because I wanted it to be basically equal to 10. So I did x times p equals 10 and solved for that. And then n times, what did I do for the second one? X times 1 minus p equals 10. Does that make any sense?
I'll be really honest, not in the least, but that's okay.
Okay. All right. I'll say it again. Okay. So for this one, it's asking, is this normally, what is the smallest value of n that will satisfy the requirements for normality for a normal distributed p hat? So I have written down that the normality for p hat is satisfied if n times p is greater than or equal to 10 and n times 1 minus p is greater than or equal to 10. Is that familiar to you guys?
Yes.
Yes.
Okay.
Requirements.
So what I did was I solved for n because they give us p. So I did n times 4 divided by 5, which I went ahead and did 4 divided by 5 and converted it to 0.8. That's what it comes out. So I basically did n times 0.8 is equal to 10, and then I solved for n. Does that make sense?
Yes.
And then I did it again. I did n times 1 minus 0.8 equals 10, and then I solved for n.
To get the lowest that it can be.
Right, to find out what the lowest n could be. And I don't know if I wrote the answer down or if I wrote a letter down. I probably was silly and wrote a letter down. Let's see, what number is this?
20.
20.
Let's see, what do I have written down for 20? Oh, for 20, I have written down 50. Which I believe that's the second one. Let's see. 1 minus 0.8 equals 0.2. Where is that? Okay. Which that doesn't. Okay, yeah, 10 divided by 0.2 equals 50. And the other one, it comes out to like way lower number. So it'd have to be 50.
But this is going to sound, what is the smallest value of n that satisfies the requirements? So shouldn't we have the smallest number?
No, because you have to have both this and that. It has to be n times p and n times. So yeah, the smallest it can be is 50 to satisfy both of those requirements. If we just went with the 13, the other requirement wouldn't be met.
Right. I remember that now. Distant memory, but it's there. We got it.
Right. Okay, 21.
I said B.
What did I say? I also said B.
Oops.
All right, 22.
Okay.
Ooh, this one I was not sure on. There was two of them that looked right to me, and I just kept looking all over the place, and I couldn't find anything.
I remember this question.
I do too. I thought this was, whoever does this experiment, that's just nasty.
Okay, so it's not A.
I went with, it's either C or D. I know that P hat is a point estimate for the whole population. So that's kind of what was throwing me. That's why I was thinking maybe it's C. But then, I don't know. D also looks right. But the thing that was throwing me off is that it says, assume the unknown true proportion is 46. So I was like, well, if we know I don't know, but they're saying it's unknown. So I don't know why. That's just throwing me off. Then maybe it's there just to throw me off from the right answer. Anyway, I'm good with C or D, whichever one you guys think is right.
I chose D because it talked about the sample, but that's my only reasoning.
Mm-hmm.
That's all I got.
Sounds good to me.
I'm leaning more towards D as well.
Let's go with that one.
Okay.
Sorry if it's wrong.
Nope, I left it in you guys' hands. I was like, the only reason why I thought it could be P is because that P hat's supposed to be a point estimate for the whole population.
Yeah.
So that's the only reason why. Other than that, I was leaning on D as well. So.
Oops. Gosh, I keep trying to print my page, you guys. Apparently.
We need a Z-score for this one too.
Okay, where did I write this one down? Where's my numbers for this? Okay, I found where I wrote that much down. Oh, good grief. Okay, so it wants us to know the probability that fewer than 320 out of the 750 suffer from one of the conditions. So I wrote down to get the Z-score for this, that we do the sample value or the proposed value minus the mean. And so to get the sample proportion, I did the 320 divided by 750 because we have like 320 out of 750. So 320 divided by 750. And then that gave me a percentage, which I didn't write down anywhere. So let me
0.426.
Oh, I did write it down. Okay, good for me. So 0.4266 is what I got. And then I did that minus the 0.45 that they gave us, which is the sample mean or the population mean. Percentage, right. And then I divided that by the standard deviation, which I had to calculate. So the way I calculated the standard deviation was I did P times 1 minus P divided by N and took the square root of that. And the P is that same 0.45. So I did 0.45 times 1 minus 0.45 divided by 750, and then I took the square root of that. And that gave me 0.01816.
0.01816? And that's the z-score?
Nope.
Oh,
so
that's
then
the
I had to
answer.
plug that back into, so where I did the 0.4266 minus 0.45 divided by 0.01816. And that gave me something that I didn't write down anywhere, which was, I mean, sure I wrote it down, but it's not like labeled anywhere near. Probably this one, negative 1.2885. Let me see if that's what I got. 0.42. I really wish I had just done this much more organized and like labeled and I'm looking at this now going, why did I do it this way? Yes, I got, so for the z-score, I got negative 1.2885.
And we are looking for the probability of
Negative
1.4.
So we're going to go to the shade to the left.
We go to the
Is that
right.
right? But it's fewer.
No,
then.
it's fewer. It's fewer.
Oh,
is
my
gonna
bad,
be
my
to the
bad.
left.
Go to the left.
It's the same number. 0.098.
8. So rounded.
I wrote 0.099.
Yep.
Yeah.
.099. Right? Look, we're almost halfway through.
To the right is, so wouldn't the 0.091 be the p-value? Yeah, that's the p-value.
So that on my test, that's a point zero. Oh, wait a minute. 0.0989.
Yes, so it should be, you round it up.
Okay, so 0.099.
Yes.
I don't have that as an option. Maybe I'm on the wrong.
Oh,
You typed that one in. It's for question 23.
Oh, I slipped down. Thanks.
Yeah.
Thanks. There you go. Okay. Good, good, good.
And then 0.091 is for question 24.
Yes, I would agree with that because I just did it.
And now we're halfway
Clarify
done.
that, 'cause I was confused too. Like, I don't have 0.99 as a choice. Okay. I skipped down.
Okay, suppose you are a dog breeder and you want to use a confidence interval to estimate the true mean fertility levels of purebred Cocker Spaniels. It is known that the distribution is normal. How many measurements must you have in order to be sure the sampling distribution of X is normal?
At least.
We
Oh,
don't
wait.
This one is any N will do, right?
Uh-huh.
Any N will do because the data is that they're using is normally distributed already.
Yes.
All right.
26.
A man?
Okay.
Oh, a men, not a man.
Okay, I calculated this one out as well. This is that one that's going to use n times p has to be this much. You know, it has to be equal than or greater to 10, and the n times 1 minus p has to be greater than or equal to 10. And I did it for both groups, and for the women, it was not greater than 10. It was like 8 point something. So that would be D, no, because in at least one case, n times 1 minus p hat is less than 10.
Yep.
Okay.
Oh, so this one would be the difference one. So UD is
Not equal to 0.
not equal to 0.
Yep. I agree.
Hold on, I'm just catching up here. 27 is UD,
Yes.
UD.
Wouldn't this be B?
Oh gosh, this is one I did not have a good time with. Because I haven't even done the homework yet for this chapter.
Oh.
Like the homework quiz. I haven't done that yet. Because I haven't had time to sit down and really go over this stuff yet.
Yeah.
Okay. But I did look it up. Okay, the residual for an observation is defined as the difference between the observed value of y, which was the explanatory or whatever they said in the thing, and the value that would have been predicted by the regression line. So no, okay. So the regression line was calculating that he would have had this much weight loss, so his residual would have been that much, but he only had 5.5 pounds less than that. So his predicted weight loss was 5.5 pounds higher than his actual weight loss.
Wow.
Wait, with the explanatory variable and pounds lost as the response.
Yes, I would say A. His predicted weight loss was 5.5 pounds higher than his actual weight loss.
Yeah, that's what I think it is.
Okay.
I mean, it's really hard to interpret all that jargon. that
Right.
I don't have enough practice with that yet. Let's see, for the study and the previous B1. Okay, so the B1 now would be the slope.
Yes.
So that would be as, and it did say percent, right? That it was, let's see, with percent compliance as the explanatory and pounds lost as the response. So I would say this one is C. As percent compliance goes up by 1%, on average, 5 pounds are lost in 3 months. Because the B1 is a slope, and that's what it would be.
Oh man, I don't know this one.
And this is as far as I got when I did my homework. So we're going to be doing the last 17 problems together. Let's see. When creating a scatter plot. Residual planning computer. Which of the 5 assumptions are being checked? Okay.
Oh, we just did this.
Oh, I looked this one up. B, D, and E.
Oh, good. I'm glad somebody
The
did this.
residuals are normally distributed.
Okay.
There is a linear relationship between X and Y, and the variance of the error term is constant for all values of X.
Excellent. Thank you, Donna.
Guys, we only have 17 more questions.
This one I found. Go figure. Okay.
Okay. What was the answer?
Oh no, I was talking about the 31. This
Yeah.
one.
The direct flights one?
Now, no, 30. Sorry, got everybody's hopes up. Sorry about that. Okay.
I have direct flight costs open still. Okay, so I'm going to put the info in.
You want the sample correlation coefficient.
Right. Oop, I'm in the wrong one. I'm in the right one. Yes. Okay, so what is the sample correlation coefficient? I forgot what that is.
That R? Isn't that the R?
Is it?
I need to open a spreadsheet. Hang on.
Because they have all these things that say coefficients on them, but I just don't, none of them say that kind of coefficient. Hold on, let me look back in the
Oh, we
list.
want to compare and find the independent stuff of them, right? So we want to find the different correlation.
I think that's in lesson 22, not lesson 23.
Yep, that's what I just clicked back to.
I'm getting my 2022.
Okay, wait, coefficient. Okay. Regression coefficients.
Okay, let's see. compute the sample correlation coefficient, and then in parentheses, it has R.
Okay.
So the question is, which column do you put in explanatory and which one in response?
I put the I don't know. Does it?
Let's see.
How would we know on this one?
Oh man. I think this might be, there was the one chapter that said it doesn't matter if you mix up X or Y. And then the two other chapters say you can't mix them up.
So maybe this is one of them.
I'm pretty sure this is one you can't mix up. Let me read the
Flip
question
them.
again.
And see what happens.
It's because the explanatory is the one that you're using to predict the response. So let's see what we can figure out here when we read it again. To predict the price of the tickets 14 days based on the 90-day price. So the 90 day is going to be the explanatory,
And the 14 days
response.
Okay.
I think I did it backwards. Let me fix that. 90 days. Copy.
So is it the 0. Sorry, I don't have the. I don't know why I'm asking. I don't have the data in there.
Okay, and you said that the correlation coefficient is the R value, right?
Mm-hmm.
So that would I have 0.780.
Since you have it in, what does the scatter plot look like?
Hold on a minute. I'm looking at something else real quick. Okay, scatter plot. Where did it go? Yikes. The scatter plot looks like, let me share my screen because, wait, how do I do that?
There's a little green box arrow thing on
Screen
the side.
share. Application window. This one. Here. Okay. Can you see it?
Oh, that doesn't look too bad. That actually looks like it has a pretty strong correlation.
Donna just got kicked out. She's trying to restart her computer right now.
Okay.
Oh no.
That looks too bad.
What are our options for the answer here?
Linear with a fairly strong positive, linear with a fairly strong negative, linear with a strong negative. So I would say B.
I would say linear with a fairly strong positive. Is that
Yes.
B?
Yes, that is B.
Okay. Excellent.
What is the y-intercept?
Okay, the y-intercept. That was, which one is that? B.
It should be on the same.
It's B0.
What?
Yes, it's 115.640.
1.5.
No, 115.640.
Oh, 115.
I wonder if I need to invite her back. And then the slope is B1.
B1 is 0.627.
Okay, sorry. Let's do the y value one more time because I did put 1.5. So 115.640.
0.640.
Okay. And my slope?
0.627.
0.627. Okay.
Predict the price of the tickets listed 14 days based on the same flight costing $200, 90 days. Give your answer accurate to 1 decimal place.
I remember doing this and thinking, oh, that's so easy. And now I can't remember how to do it.
Oh, good grief. I'm glad you remember doing it because I sure don't.
You'll need it for the homework. So that's the only reason why I remember. So it's
It's going to be times the slope, I'm sure. Like you have to do something. Oh, anyway, you go ahead and tell me what you think you remember before I start spouting off.
So isn't that X in our predicted line over here?
Oh yeah, vaguely remember like something like that. Yes, you put 200 in.
Yeah.
Okay.
And then it comes out to 2.
Or, but shouldn't you put it as the days and not the, hold on.
Yeah,
That's our X value. Oh yeah.
Donna,
So
while you're figuring this out, can you hear me?
I can hear you now.
That's
scary.
Are you back at 31?
Yes, I am.
Okay, let's catch Donna up first.
yeah.
Okay. Wait a minute. Getting there. Okay, 31. Did you guys find an answer?
It's
Yes.
0.780.
0.780? Okay.
32 is B.
And that's linear with a fairly strong positive association.
Mm-hmm.
Okay.
And then 33 is 115.640.
Okay.
And then 0.627.
Thank you. All right.
And we're on 35 right now.
Boy, you guys were zipping right along while I was panicking with a black screen. Right.
Okay. So for this one, I remember now, you just put in the number that they're telling you in the X box on the thing, and then it spits out the predicted. That's why you were remembering it was so easy, because it's like super easy. And that's why I don't remember it, because it was so easy. I didn't even, think I needed to remember that. Anyway, so that when I put 200 in X, then it spits out 240.979 for the predicted.
0.979.
Yes, but
So
it tells us
98. Wait,
it's just going to be
2.
It's going to be
41?
2.41.
Yeah, 2.41.0.
Yep.
Okay, one more time, because I've got 240.979.
So now round. Round it.
One more time, 35.
241.0.
241.0.
All right, for the next 3 questions, conduct a 95% confidence interval for the slope of the regression line obtained when 90 days before flight ticket prices are used to predict 14. So now we're using 90 day for 14. Is that what we were doing before, or we were doing exact opposite?
We were finding. Oh no, that should be what we're just finding our lower bound. What is our lower bound?
It's
Going into
8.4 something.
Wait, no, here we're using 14 day. Wait, no, we're using 90 to predict 14.
Yes.
That's what we're still doing,
14,
right? 90.
Yeah.
Okay.
So is it the 84.654?
84.654.
Right? It's the lower bound confidence interval. Oh wait,
Yes.
why did that just change?
That isn't what I have. I have 80 point.
I'm sorry, I was looking at the wrong thing, but I swear it just said 84 a second ago.
Wait, I don't remember which one of these confidence interval we use.
You want to do it for the slope.
So,
Oh,
yeah.
okay, good. Okay, so I have 0.518.
0. This is what I got wrong on the last quiz, and I had to do it again. I got all 3 of these wrong because I used the wrong thing.
So one more time for 36.
0.518.
And whatever spreadsheet you just pulled up right there is where I got 84.
Oh, am I still sharing?
Yeah.
Can you guys see?
Uh-huh.
Can you see what numbers I'm looking at?
Yep.
Okay, so then oh wait, what did I tell you? Was that the upper bound or the lower bound we just did?
That was the lower bound that
Lower.
we just did.
Okay, and so then the upper bound is going to be the 0.735?
Yeah.
Okay.
Minus
Set a timer for 2
minutes. 735 equals this. And it's divided by 2, right? I
Yes.
got negative 0.108. That sound right?
Sure.
Okay.
You can always double
So
check.
just double checking.
I can't remember how to do that one.
735 minus 0.518.
Oh, I did those the other way around.
Yeah, it's your upper bound subtracted your lower bound divided
Got
by
it. 735 minus 518 divided by 2. Well, I got then a positive.
Yeah, that sounds better.
And isn't it 109? Sorry, we got to round up.
Yeah, 0.109.
Yeah, 0.109.
I have to pee really bad, so I'm going to put you guys on mute, and then
Me too, bathroom break.
taking too long. I'll be right back.
That's funny.
So long, my son just brought me a hamburger saying, "It's time for dinner, Mom, here."
Oh, cute. That's nice.
Now I was just sitting here looking like a hamburger. But we're almost done. Yes, what, 7? 1, 2, 3, 4.
Number 39 is the last one.
The HOB1 equals 0. This stuff confuses me.
At least I think it is.
Can you guys I just want to make sure I got the numbers right because I was getting some echo here. Back on 33, could you just run up till where we left off?
Yeah, 33 is 115.640.
Okay. 34.
0.627.
Okay. And 35.
241.0.
Great. Thank you very much.
Good.
Oh man, now I'm second guessing myself.
Wait a minute. What are we second guessing on?
I was
Number
double checking my number.
39. If it's B or D.
For number 39, oh, I hate these ones so very much.
Right.
I always get them wrong.
Determine if the slope of the true limit is not 0.
Choose the correct null and alternate.
Is this lesson 23?
Yes.
And because it's a slope, I know it's B1, but I can't remember if it's beta 1 or just B1.
I think it is because if you look at lesson 23, that's there's both numbers. I was going to say, most of the information is, the equations are betas. Look, it says right here.
First rule,
It is. It's beta 1 equals 0.
then it's D, and I was right.
Yes. Very
Which
good.
one? Which one?
D as in dog.
It's beta 1 equals 0 for the null hypothesis.
Right.
Yeah.
Okay. Okay. Awesome.
Wait. I'm just catching up. I got to 39. Where are we?
39 is D as in dog.
What
And
is the
that's,
value of the test?
The beta 1, and then beta 1 is not equal, right?
Yes.
Okay.
Okay. So I do not know how to do this.
So I got this wrong because I thought the test statistic was R, and it's not. It's actually the T.
Yeah.
Yeah.
Is it
So
the
it's-
T on the one that we already just did?
Mm-hmm.
So I have T is 6.525.
6.525.
And then what's the p-value?
It's to the right.
It's 4.4999 to like e to the negative 0.9.
So
So isn't it 0.00?
0.000.
Yeah. Yep.
I really hate those ones because
Me
it really
too.
should just be 0.
Right.
Yep.
So in this case, we would reject our null hypothesis.
Yes.
Because there is sufficient evidence
Mm-hmm.
to suggest that the slope is a true linear regression, blah, 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 blah.
You said because there's sufficient. There is sufficient.
Yes.
Okay. I thought you said make sure.
Oh gosh, these are the ones I don't like.
I don't like these either.
Okay, let's see. What do we have? The mean birth weight for babies is this. They want us to. Okay, so this is going to be where we have 2, but they're not dependent.
But all of our mothers are in.
We don't have 2 groups. You just have the 30 mothers.
Yeah,
Oh,
we just have one. So I would go with a one sample t-test.
Okay.
Yeah.
Yes.
What's the difference between the Z and the T?
The t-test, you do not know the standard deviation.
Okay.
So close. 4 more questions.
this has got the standard deviation in it, so I
Yep.
go for the one sample Z.
Me too.
Agreed.
T-test.
Wait, this is dealing with the proportion.
Yeah.
They have the
Oh,
percentage.
sorry.
That's the key.
One proportion.
Test of one proportion.
Yep.
This is percentage.
Looking pretty good. Have to admit.
So,
Test of 2 proportions, I'm guessing here.
totally a guess for me also.
I'm gonna there we are comparing 2 different proportions, so would it be a test of 2 proportions?
I think so.
That's what I pick.
Okay.
And the last one, since they're talking about relationship, linear relationship, I'd go for linear regression.
Me too. Me too.
Okay, who wants to submit first?
I'll do it. I'll jump on that grenade. Very nervous.
I know, I don't want to spend a lot of time doing this over.
We missed number 7. Number 7 was the one that I was thinking, it could just be, you don't know. Anyway, number 7 was the one about the skewed data, whether if it was right skewed. It's definitely we cannot be sure. So.
Oh, that's what I put. What did you put?
It's not that. It's we cannot be sure is the wrong answer.
Got it.
Oh, then I would change it to right skewed.
Right skewed, yeah. And we missed number 17.
17. Oh no. I remember this one. What chapter is it from? I'll pull the quiz up.
I don't know. Number 21 is not right either. And 24 is wrong.
Stop it.
28 is wrong. 40 is wrong. And that's it.
That's not too bad.
We got an 87.
Oh, that's not awful.
40 is what's the value of the test statistic? We put 6.525.
As long as it's as long as it's the line with the slope.
Think that. Oh, I don't know. I don't have that data put in.
Oh no, but then we put the wrong one, and it's supposed to be 11.510.
Okay, and that was number 40.
Yeah.
You said 11.510?
Yeah.
Okay.
Oh my gosh, it's all the way down here. Holy cow.
So
Okay. Hold on. 11.510.
10.
Okay.
his predicted weight. So for 28, we chose his actual weight loss is 5.5 pounds higher than his predicted weight loss.
Then I would choose B.
Yeah, we go with B then.
Lindsay, do you want to open your test again and we'll give you all the answers real quick?
Okay, sure. Wait, so did we get them all changed already?
No, not yet.
So what about
So that was
24?
24. We put that, which one is the following is the p-value, and we put 0.91.
Yeah, so what would it be?
Well, hold on. It might be give me 1 second. So 1.334. It might be the 0.909, or yeah, 0.909, because we might have to do the middle as well. Shade the middle and the right.
Okay, wait. Suppose you're testing p equals 0.6. It's I bet it's that divided by 2. The 0.91, let's see what that comes out to be.
It says that
Why would we divide it by 2?
curve is 0.91.
Because it's a not equal to one, so it's going to be a two-tailed. So it's going to be 0.46. I'm going with A on that one.
Okay.
Yeah, what was next? Number 21.
Yeah, 21. Ew, yikes.
should we have?
Maybe we should have used the 0.233.
Yeah, that's deciding which is the P is always the hard part for me.
Yeah, me too. I know it's definitely not A.
Yeah, it's
And I
definitely.
know it's not C because that has nothing to do with how you decide normality for these types of tests. So the only other one it could be is D.
Is D. All right.
Yeah. Okay,
Process of
so
elimination.
is that all of them, or is there still another one we're figuring out?
There's one or two more. 17.
17 was one.
Oh gosh. This one too.
Oh, 17 is not B.
Well, it's definitely not A.
Mm.
I don't know how this could be any. The sample size is not large.
Of the differences.
They create a QQ plot of the distances.
But the differences are only between 10 homes.
I mean, the only thing the only other one I would say is C.
Did we get 15 wrong too?
I think so.
No, 15 we got right.
It was like 7, right?
Yeah. I wrote
Yeah,
down,
7.
yeah, 7, 17, 21,
Okay.
24, 28, 40.
Want me to submit really quick?
7 is probably skewed right.
Yeah, that's what we decided was it was skewed right.
Yeah.
All right, I'm gonna submit really quick. Let's see. Well, we did better. We missed one.
Which is what?
There's so many on here. We missed number 24. It is not A. I don't care. I'm fine with this. So,
Okay.
Lindsay, I'm going to open the test again and I'll give you all the answers.
Yep, I'm opening it right now.
It'd be such a pain to write them all down and then have to
I
go.
know, right?
Right.
Okay, true on that. Okay, 2.
I'm going to go with D. For number
So,
24.
number 2 is C.
The number of people.
Yes, the number of people. Number 3 is an observational study because they have no control over the prices of cereal. Number 4 is also C, if not possible to determine.
Okay.
Number 5 is 2.5.
Okay.
Number 6 is 146.8.
Okay.
Number 7 is skewed right.
Okay.
Number 8 is 2.236.
Okay.
Number 9 is 0.991.
0.991.
Yes.
Okay.
Number 10 is type 1 error, B.
Okay.
And number 11 is C and E. Approximately 95% of all 95% confidence intervals that could be computed from the population of all adult females in the United States will contain true mean height. And we are 95% confident that the true mean height of adult females in the United States is somewhere in the confidence interval.
Okay.
Number 12 is B. Yes, the distribution of sample means is normal. The data is normal.
Okay.
Number 13 is 0.019.
Okay.
Number 14 is B, dependent sampling.
Okay.
It's the 2 couples. Number 16 is A. No, because the
What's 15?
0.096. Sorry, skipped right past that one.
Okay, and 16?
Is A. No, because the p-value is greater.
Okay.
17 is C. Yes, the distribution of mean differences is normal.
Okay.
18 is C. It's UD equals 0. I can't remember how to say that right now.
Yeah. Okay.
19 is B. 95% of all 95% confidence intervals contain the true mean.
Okay.
20 is 50.
Okay.
21 is D. 40 times 0.233.
Okay.
22 is D. 51.2% of gametes have the sample male chromosome in the sample. Number 23 is 0.099.
Okay.
And then 24, I don't know what it is.
It's 0.182 because I put 0.909 and it's the 0.091 times 2, which is 0.182.
Okay, so it's times 2, not divided by 2.
Divided by 2.
Yep.
Okay.
So it's 182.
Okay. Cool.
25 is any N will do. I don't know what letter that is.
Okay.
26 is D. No, because at least one case is less than 10.
Okay.
27 is not equal to 0. Sorry, UD. How do you say that?
UD.
Mean of D.
What?
The D. Mean of D.
Mean of D.
Or mu of D, rather.
UD equals 0. Not equal to 0.
Okay.
28 is B. His actual weight loss is 5.5 pounds higher. You were right the first time on that one.
Okay.
Then we talked ourselves out of it.
Yeah.
29 is C. Percent compliance goes up 1% on average.
Okay.
30 is B, C, and D. Residuals are normal. Linear relationship between X and Y, and the variance error term is constant.
Okay.
31 is 0.780.
Okay.
32 is B, fairly strong positive association.
Okay.
33 is 115.640.
Okay.
34 is 0.627.
Okay.
35 is 241.0.
Okay.
36 is 0.518.
Okay.
37 is 0.735.
Okay.
38 is 0.109.
Okay.
39 is D. It's beta 1 equals 0. 40 is 11.510.
Okay.
41 is 0.00. 42 is reject the null. There is sufficient evidence.
Okay.
43 is B, one sample t-test.
Okay.
44 is a one sample z-test.
Okay.
45 is a test of two proportions.
Okay.
46 is a test of two proportions.
Wait. 45 was what?
45 is a test of one proportion.
Okay. And then 46 is 2.
Yes.
Okay.
47 is the linear regression.
Alrighty.
Cool.
Hopefully I typed all that in right.
Right. I'm going to stop our broadcast.